The lesson today is actually just a quick revision of effective interest rate, annuities, and perpetuities. You should know what an effective interest rate is. So you could either use this formula, which is in your formula sheet to work out the effective interest rate, or you can use your class bet, interest conversion. So make sure that you know this N is the same as the number of compounding period, and this APR is actually the nominal annual interest rate. Of course, if you've got the effective interest rate, you want to find the nominal interest rate, use your class bet. Probably make life a little bit easier rather than using the solve function. Either way it's fine, but if you've got an effective interest rate, I'll just recommend you using the class bet, that's all. Alright? Now, next thing, annuities and investment, and in fact, reducing balance loan using recurrence relation are all this equation, that's all. Basically, minus means you're withdrawing at a particular time frame. So this is withdrawal for negative, or whatever payment from the bank, alright? Or you withdraw from the bank or the payment from the bank. Plus is when you add in. Say you have put in certain amount of money in initially, then every 3 months, putting extra money in. So that is for investment. Basically, use the same equation. Plus is for adding in investment, minus is for withdrawal. That's for recurrence relation. Now notice that the N, I'm going to highlight this N plus 1, N and T naught. They are all related to the sequence number. They are not N, which is the number of compounding period. Alright? Again, next thing, if you look at recurrence relation with index withdrawal, which is for annuities only. So when you have index withdrawal, you are withdrawing certain amount of money with certain percentage increase. Again, I'm going to highlight this, and this. They are all related to N. Now, I recall that when I first introduced this concept, I actually state that this is N. In fact, I made a mistake there. It should be N minus 1, because after the first period, that would be just D times 1, and 1 minus 1 means anything to the power of 0 is 1. So therefore, recall, this must be N minus 1. Alright? So index withdrawal, which means you've got amount of money you want to withdraw, but you're increasing every withdrawal. Say 1%, 2%, or whatever. Alright? Now, you can use recurrence relation to model the situation where the number of compounding period is greater than the number of payment period. So in this case, CY is greater than PY. You can't do it the other way. If PY is greater than CY, use your financial function. Alright? Again, plus or minus. Plus is you put your money in, minus you take your money out. Alright? Now, the other thing that I have to again highlight the N here. I use a different color deliberately. Is to, not this one, is actually to do with the term number, that's all. The recurrence interval. Alright, it's not the N, which is number of compounding period. Again, index withdrawal, recall, this should be N minus 1 and N. Alright, these are the N related to the term number, not the number of compounding period. Alright, let's have a quick look at the calculator. If you use class bet, of course you need to know how to use your compound interest. That is probably the most useful one. You must be able to work out your principal as negative if you are putting your money in. All right, so you're putting your money into a bank or any investment. You are not actually your money is out of your pocket, therefore you put it in as a negative. Whereas if you're borrowing money, it will be positive because the bank has given you the money and it's in your pocket. All right, think about it that way. Right, amount withdrawal from each period, because we are withdrawing from the bank, therefore it is positive. Future value is final amount. So PY is number of payment or number of installment per year, and CY is number of compounding period. Note, PY equals to CY unless otherwise stated. Only when it's stated, then you know that PY is different from CY. Let's quickly have a look at the situation when PY is different from CY. This is related to PY. Alright, so number of payment or installment period, say, let's use this example. If the interest is compounded annually but the payment is quarterly, so payment is 4, CY is 1. Let's say it is 20 years. So it's 20 years times 4, which is 80 payment periods. So this is how you work out N. Make sure that you know N is related to your PY. Now for a perpetuity, all we want is to maintain the principal. We are not withdrawing any principal, so therefore we are only allowed to take out the interest. Let's have a look at this example. Now before I go on to this continue on with this example showing how to do it, I would like all of you to just take note of question D. I have changed the wording of question D slightly. Alright, so take your time quickly, have a quick look and update the handout that I gave you. Alright, let's have a look at question 1 and question A and B. So at the age of 60, Sandy invested 500,000 into an annuity which pays an interest rate of 4.8% per annum compounded quarterly. Alright, so I know CY equals to 4. So PV, present value, is minus 500,000. Alright, now you know she would like this annuity to last 20 years. So N is therefore equals to 20 times 4. Alright, so here, that's what we need to do. For part A, we need to find out the amount she could determine. Therefore, we actually have to use the financial calculator. We cannot use recurrence relation. So N is 20 times 4, which is 8. 80, I is 4.8%. PV is minus 500,000. PMT we don't know. Future value is 0. PY is 4. CY is 4. If you use your calculator, or once you use your calculator, you should know that this is 9,757.479885. So therefore, Sandy can withdraw, or I should say, Candy will receive. Just follow the question. Sandy will receive 9,757.48 per quarter. Alright, now part B. If Sandy would like to have spending money of 10,000 per quarter, how long will this annuity last? So this time we don't know what N is. We know PMT is now 10,000. So N we don't know. I percent is still 4.8. PV is minus 500,000. PMT is 10,000 this time. And future value is 0. PY is 4. CY is 4. And using your calculator, it should be 76.8147. So therefore, the annuity can last 19 years and 1 quarter. Now in this case, you can use your recurrence relation. If you are using the recurrence relation, is Tn plus 1 equals to 1 plus 0.048 divided by 4 times Tn minus 10,000. Because we do know what the withdrawal is, and there and T naught is actually equals to 500,000. Using your calculator, you should work out is between T76 and T77. Now let's go to the calculator. Alright, let's look at question A and B using your calculator. So under financial, we go to compound interest straight away, and you know that N is 20 times 4, which is 80. If you want to type in 80 straight away, that's fine. 4.8%. PV is minus 500,000. PMT, we don't know. Future value is 0. And PY is 4. CY is 4. And therefore, PMT, oops, incorrect because I typed in 50,000 instead. Now, that's better. 9757.479885. That is how you could do part A. Part B, this time we change the PMT to 10,000. And tab N, 76.8147. In fact, it's 8148. I should have 81479. 8148. So therefore, you know that it's about 77 quarters, which is 19 years and 1 quarter. All right. If you want to use your recurrence for part B, recurrence relation, let's go to menu under recurrence sequence. All right, go to recursive rule rather than explicit rule. So here I know that would be AN times 1 plus, using your keyboard, 0.048 divided by 12 minus 10,000. And this is 500,000. And tap on that, and let's click OK. If you keep going down, oops, I might not have done enough of, oh yep, that's not 12, that's actually 4. My fault. I need to go up there again, and I don't want to show the sum, and let's go tap on that. All right, let's see. Oh, I haven't done enough entries, so I'm going to change that to, let's say 80, and click OK. All right, let's see. You've done that. Yep. So you know that you can see that it's 76 and 77. So it will last 76 and a bit quarters, or just 77 quarters, which is exactly what you've got as in using your financial part of the calculator. All right, let's move on to the to part C and part D. All right, part C. Sandy has decided that she would like to withdraw 8,500 the first quarter, and then index it by 2% per quarter. So we know that it is going to be indexed. So let's start off by writing a recurrence relation. We know Tn plus 1 equals to Tn, or you can use 1 plus 0.048 divided by 4. This time is take away 8500, 1.02% to the power of n, right? And then T naught equals to 500,000. So using your calculator, we should work out that T48 equals to 21268.6952. T50 equals to minus 466.1788. So therefore, the annuity will last 48 divided by 4 is 12 years and 1 quarter. Alright, let's see what we can do. Alright, part C, we're going to change it slightly. This time, same recursive in relation, except we are going to change the last bit. Instead of 10,000, we are going to change it to 8500 times 1.02 to the power of n. And let's tap on that. Alright, let's keep going. And we can see that it's the same. T48 is 2.268.6952 and 49 is minus 466.178. So this is how you use your class pad. Alright, part D and part E. So this time, Sandy is considering the option of withdrawing 18,000 every 6 months. Alright, so here, PY equals to 6. Determine the initial investment of the annuity that would last 20 years. So note that we don't know the PV. We are looking for the PV. Now, since the question did not specify the interest rate, we'll assume that it's still 4.8% per annum compounded quarterly. We have to do that. So here, CY is 4. So D will then be N equals to 20 times, actually no, we can't do that. We don't know what N is. Alright, so what we need to do is, and we don't know, I% is still 4.8%, and we know that this time PV is still minus 500,000. PMT is now 18,000. Future value is 0. PY is 2, actually, not 6. Every 6 months is 2. 2, and the number of compounding period is actually 4. So half yearly is 2. So if we work that out, n, we will work out what n is. Alright, I will go through the calculator and then we'll sort it out in a few minutes. And let's quickly look at part E. So part E, we now know is we want just the interest, so it's therefore 500,000 times 0.048 divided by 4, which is 6,000. So Sandy can withdraw 6,000 per quarter. Alright, from here, let's go to the financial function. So the financial function this time, what we're going to do is, and we don't know. We know I is still 4.8, PV is 500,000, PMT now is 18,000. Future value is 0, payment is 2. The number of compounding period is 4. So type in N is 46. N is now 46.55, 46.5557. All right, we can go back and answer the question. All right, let's answer part D now. So we know N is 46.5557. Therefore, this is actually, because this is 2 times the number of years, so therefore we need to divide 46.5557 by 2. So we know that 46 divided by 2 is actually 23. 23.5 divided by 2.25, so that's actually 23 years, 23 and a half years. So yes, the investment or the annuity, actually I should say annuities, will last 23 years and 6 months. All right, that is the end of the lesson.